In this video, we'll continue to look at confidence intervals, this time using them to estimate means. Have you ever been to the emergency room? It's not a lot of fun, to put it mildly. And one of the worst parts about it can be sitting around, waiting for someone to see you. Suppose that, being fed up with the sad state of the emergency room at a particular hospital, you decide to do something about it, and you start with a survey, asking how long recent patients have had to wait before being seen in the emergency room. You survey a simple random sample of 40 people, and the wait times you get have an average of 33.8 minutes, with a standard deviation of 9.9 minutes. Based on this data, what can we conclude about the true average wait time at this hospital? This is another application of confidence intervals, and the process is very much the same as with proportions. First, we need to check our conditions. In this case, there are 3 conditions we need to meet. First of all, our data need to come from a random sample, which we already said we'd satisfied. Second of all, in order for the central limit theorem to apply, either our population has to be normal to begin with, or our sample size has to be at least 30. Ours was 40, so we're good there. And finally, our sample size has to be less than 10% of the overall population. In this case, that means our population has to be at least 400. Since there have most likely been more than 400 people to go to this emergency room, we should be fine. Now, there's one small caveat that we have to be careful of when it comes to means. Before we go any further, we have to figure out whether sigma, the population standard deviation, is already known. That's a very important piece of information, and it'll determine whether we should use a normal distribution or a related but slightly different distribution called the student t distribution. Let's assume for now that we already know the population standard deviation. That is, the standard deviation in true wait times at the hospital is 10 minutes. Maybe we know this from a previous study. In that case, we can use the normal distribution, just like we did with the proportions. We'll pick a confidence level, like, say, 95%, and that gives us a critical z-value of about 1.96. From there, we can compute the margin of error, our critical z-value times the standard error, that is, the population standard deviation sigma, divided by the square root of the sample size n. In this case, that's 1.96 times 10 divided by the square root of 40, and that comes out to about 3.1. That now gives us everything we need to construct our confidence interval. Our sample mean was 33.8 minutes, and we just found that the margin of error was about 3.1 minutes. So that means that the true population mean could be off by about 3.1 minutes in either direction. That gives us a confidence interval of between 30.7 minutes minimum and 36.9 minutes maximum. So now we can interpret our confidence interval. We are 95% confident that the true average wait time in the emergency room is between 30.7 and 36.9 minutes. Remember to phrase it in terms of confidence, not probability. There's not a 95% chance that the true average wait time is between these two numbers. Either it is or it isn't. Rather, what we're saying is that if we were to repeat this experiment many times, sampling 40 people each time, but potentially getting a different sample mean for each sample, then 95% of the time, our confidence interval would capture the true mean. So that's what we do when we know the population standard deviation, sigma. Now that raises the question, what do we do if we don't know sigma? In that case, we have to tweak our process by just a little bit. See, up to this point, we've been able to use a normal distribution. But if we don't know the population standard deviation, that introduces some extra variability on our results that makes the normal distribution potentially inaccurate. But we can compensate for this extra variability by using a different distribution called the student t distribution. The t distribution is still bell-shaped, but it's a little shorter and wider. In particular, it's narrower in the middle, but it has more probability in the tails than the normal distribution does. which accounts for the extra variability that comes from not knowing sigma. This t-distribution slightly changes how we proceed with the rest of the problem, though it's still pretty similar. For example, instead of finding a critical z-value, we now find a critical t-value. That t-value depends not only on the confidence level that we want to set, but also on the size of our sample. The t-distribution has an extra parameter called the degrees of freedom, or df for short, which is just equal to the sample size minus 1. The degrees of freedom slightly alters the shape of the distribution, so it's important to remember to include it. In our case, we surveyed 40 people, so our degrees of freedom would be 40 minus 1, or 39. We can use the Excel command t.inv.2t, followed by 1 minus our confidence level, expressed as a decimal 0.95 here, and then our degrees of freedom, 40 minus 1. We end up with a critical t-value of about 2.02. That's slightly bigger than the 1.96 we got with the normal distribution, because we're accounting for that extra little bit of variability. From here, now we find our margin of error. Again, the formula is very similar to last time, except we use the critical t-value instead of the critical z-value. And instead of the population standard deviation sigma, we use the sample standard deviation s. Once we run through it, we get a margin of error of about 3.166 minutes. That means that now our estimated mean wait time of 33.8 minutes might be off by as much as 3.166 minutes in either direction, and so our confidence interval is just a bit bigger. But the way we interpret it is exactly the same. We are 95% confident that the true average wait time in the emergency room is between 30.634 and 36.966 minutes. So here's an overall summary of everything we've said for confidence intervals for means. The biggest things to look out for are the conditions that allow us to construct confidence intervals, and the effect that knowing the population standard deviation sigma or not has on whether we use the normal z distribution or the student t distribution.